Let us go through the list of windowing functions supported by Postgres. We have lead and lag as well as first value and last value. We can either use order by sort column or partition by partition column, order by sort column while using windowing functions. This approach of order by sort column is used to get the windowing done on global dataset. If you want to perform windowing within each partition, then we use this approach of using partition by partition column, order by sort column. Both of them are specified using over clause while using the windowing functions such as lead, lag, first value and last value. Let's load the SQL magic, and also let us create this environment variable called as database_URL. It will facilitate us to connect to the database using Jupyter based environment to run the queries. Let us understand lead and lag functions to get column values from following or prior records. Here is the example to get values from either immediate prior or following record along with values from current record. We will get values from prior or following record based on order by within or clause. You can see the syntax here. We have used lead, then order date over order by order underscore date DESC as prior date, and these brackets are mandatory. You have to specify partition by and order by clauses under over using circular brackets like this. That being said, this will give us the prior day's date and prior day's revenue because we have sorted the data in descending order. Even using lag, we should be able to get prior day's date as well as prior day's revenue, but the data has to be sorted in ascending order if you use lag function. So lead or lag can be used, but the order by will change. Just keep that in mind. Now let's run this query. You can see the results. We got the date, revenue, prior date and prior revenue computed using lead, and also lag prior date and lag prior revenue computed using lag. You can see that the overall data is sorted in descending order by order date. That's why we got the latest date in our dataset at the top. The latest date is 2014 July 24th, and the revenue is $50,000.85. The prior day's date is nothing but 2014 July 23. The revenue that is generated on that date is nothing but this one. So this is how you should be able to leverage lead or lag to get the prior day's date or revenue. In this case, in general, it is nothing but getting prior records information along with the current record information. So this is current record information, this is prior record information. If you want to get the following record information, then you just have to say lead, and when it comes to the data, you have to sort in ascending order. If you want to use lag for the same purpose, you can use lag, specify the column on which you want to get the following record. Then as part of order by clause, you have to sort the data in descending order. That's how you should be able to get the following records information. On top of getting information from prior or following immediate record, we can also get values from prior or following nth record. Here is the example to get values from either prior or following 7th record along with values from current record. You just have to pass second argument to lead or lag function like this. It will just get us this 7th record details. So in this case, if I run this, you can see that the latest record belongs to 2014 July 24th and the revenue is this one. The 7th prior record have the date of 2014 July 17th and the revenue is $36,384.77. This is how you should be able to get either prior or following nth record along with values from the current record. For values related to non-existing prior or following record, we will get nulls. So in this case, let me run this. If you observe in the previous query, we have order by order date DESC. Now I am sorting the data in ascending order by removing the DESC. Now you can see that the first record belongs to 2013 July 25th. Revenue is $31,547.23. The previous record doesn't exist for this, and hence we can see the nulls here or nulls here. They are actually nulls because we are using Jupyter. They are displayed as nulls. As we are getting null values, we can actually replace them with more appropriate values. Some cases it might be relevant. If you want to replace nulls with more appropriate values, you can actually pass them as third argument like this. We can replace nulls by passing relevant values as third argument. However, the data type of the values should be compatible with the columns on which lead or lag is applied. So in this case, this will work. You can see that with respect to prior revenue, we got 0.0, which is of type float. Revenue is also of type float, and hence it is working. With respect to date, we do not have the third argument, and hence we are getting nulls here. People might get tempted to use something like this, n/a, which means not applicable. However, order date is of type date, and not applicable is of type string. And if you run this, you will see the error. So you cannot just replace the nulls with whatever you want. The values which you are trying to replace should be compatible with the data types of the columns which are specified as part of the lead or lag function. So let's fix this. Let's remove this not applicable from here and run this. You can see the results as expected. Here is another example. So in this case, we are using daily product revenue. Within each date, I just wanted to see the top performing product and then next top performing product and so on and so forth. So I want to see the top performing products at top and worst performing products at the end. So we should be able to run the query. You can see the details here. We got date, product ID and revenue. Within each date, we just want to get the current record as well as the next record, which is nothing but top performing record and the next top performing record. You can see the output here. So in this case, we have said lead of order item product ID over partition by order date, order by revenue DESC. Similar to that, lead of revenue over partition by order date, order by revenue DESC or descending. And you can see the output here. We got the date, we got the top performing product within that date and the corresponding revenue. Then the next top performing product and the revenue for that product. You can compare this output with this. These two match. So this is how you should be able to get the current record details and then the following or prior record details so that we can compare the two for some advanced analytics. So make sure you are comfortable with the lead and lag functions to solve the business requirements such as I have demonstrated here. Let us see how we can get first and last value based on the criteria. Min or max can be used to get only the min or max of the metric we are interested in. However, we cannot get other attributes of those records. If you want to get other attributes of such records, then you have to use either first value or last value. This is how the syntax of first value will look like if you are trying to get the attributes of min or max within each partition. You just have to say first value, then the attribute over. As part of the over, you can specify partition by like this and then order by. If you want to get the maximum metric attributes, then you have to sort the data in descending order if you are using first value. If you are using last value, you have to sort the data in ascending order. We will see the example with last value at a later point in time. Keep in mind that with respect to last value, the syntax is a bit more tricky compared to first value. With first value, you just have to say first value, the attribute from which you want to get the information, then over, then partition by clause, then order by clause, either in descending or ascending depending upon your requirement. In this case, I am trying to get the top performing product details with each and every record. That's why I have sorted the data in descending order by revenue. On top of order item product ID, I also want to see the revenue itself. In this case, we can also use max of revenue and then we can just say over partition by order date. We don't need to use this if you want to get the revenue details. With all other attributes, you have to use this approach. With revenue, you have an alternative approach also. You can actually say max of revenue directly. Now let me run this and you should be able to see the results. If you want to see the output with max as well, you can copy this and then paste here. Then say max of revenue like this. With max, order by is optional. You can remove this order by. Then let's say max of revenue or max underscore revenue, and you should be able to see the output. So first revenue and max revenue are same. Max revenue can be leveraged to get the metric. However, if you want to get the other attributes related to that metric, then you have to use first value like this. We can also achieve this using last value. Let's see an example with last value. While using last value, we need to specify window spec saying rows between current row and unbounded following. As emphasized earlier with respect to cumulative aggregations, each and every window function will have a window spec. However, we should be able to leverage the default one and we don't need to override it unless and until we use functions for cumulative aggregations or moving aggregations. And the scenario where we might have to specify custom window spec is when we use last value. When it comes to the default window spec for last value, it is nothing but rows between unbounded preceding and current row, which means within each partition based upon the column on which data is sorted between first record and the current record. For the current record, it will be the same as whatever we have for the original record itself, and hence we'll be seeing the same original record attributes even when we use last value, which beats our purpose. For that reason, we have to customize it, and let's see an example, then you will understand. So in this case, I am saying last value of order item product ID over partition by order date, order by revenue. So the data is partitioned using date and sorted in ascending order by revenue. And also I am using last value on revenue. This time I have specified the window spec saying that rows between current row and unbounded following, which means starting from current row till the last record within the partition based on partition by order date and order by revenue. So the window spec up to this point is same as order item product ID, but it also have this additional part. Now let's run this and let's see the output. So with respect to last product ID and last revenue, you can see that last revenue is reflecting the maximum revenue, which is nothing but $5,599.72 with each record. However, when it comes to product ID, it is same as the original product ID. You can see here, because there is no window spec which contain the range, and it used the default one, which is nothing but unbounded preceding till the current row. Now if I copy this one and paste here, then run this, we should be able to get the results we are looking for. We got the correct product ID for each and every record in this case, which is nothing but the product ID of the highest revenue generating product. This is how you should be able to leverage the last value to get the same information as we have seen earlier. Once again, I am reiterating, to get the maximum revenue, we don't need to actually use last value in this case. We can just say max and then max of revenue over partition by order date, and this entire part is optional, or it can be removed. We might not be able to even use them. So when we use functions like max or min, we don't need to specify the order by clause. It will directly give the maximum value within each partition. Now you should be able to run and you should be able to get the results. So this is how you should be able to use the last value to get the attributes of the metrics we are looking for on top of the metrics themselves. Without first value or last value, we will not be able to get the other attributes of that metric.